Hey guys, we are welcome to another tutorial in the same GET 201 Basic Electricity Example 4. Okay, Example 4, we have a question here that we want to tackle, and as you can see from the preceding video, which is the previous one, this one is just figure C. This is figure C. The other one was figure B, so this is figure C. Alright, so the equation is 3-point charges. 3-point charges of, look at the 3-point charges. These are the 3-point charges. These are the 3-point charges are placed at the vertex of an equilateral triangle. What is equilateral triangle? Equilateral triangle is a triangle that has equal angles. That's why I say it's equilateral. It's a triangle that has equal angles. That is equilateral triangle. Okay, so we say the vertex of an equilateral triangle which has sides. That is, the sides are the same as I already say about equilateral triangles. So it has a size of 10 cm long, 10 centimeter long. Find the force on each charge. You should find the force on each charge. So we have how many charges here? I have 1, 2, 3, 4. As you can see, it's A, B, C is here, D and E. So you have 1, 2, 3, 4, and 5. Those are charges. So they ask us to find the force on each charges. So we are going to find the force on each charges. So first thing, we're going to have our solution. All right, so if you have our solution, what are we going to do? Now we have a condition in this place. The condition of the problems are represented in figure 5C, as you already know. The condition of this problem that we just read here is represented here. Now we are going to consider this plus 5U that is placed at the corner of, now look at it, we are going to have plus 5UC. We are still going to have plus 5 something like this, and we're still going to have plus 5. Now these things are the charges, they are the charges. So how are we going to solve it now? Let's consider this charge that is placed at the corner of C. Where is C? Look at it. Where is the corner of C? Look at it. Understand? So we're going to consider this charge. Why are we considering it? Because it has been repaired by the charges of A and B. Remember, like charges repair each other. So this charge here has been repaired by these two charges. This charge placed at the corner of C here has been repaired by these two charges along this. All right, along A, B, and D. Along A, B, and D, and it's also replaced along B, C, and what? E. It's also replaced along B, C, and what? E. Because the charges, if the charges are going like this, you understand that this charge has been repaired by this one. This one will repair this one, and this one will repair this one. So this charge is being repaired by this one and this one. I hope it is clear. All right, so these two forces are now what? Equal. These two forces are now equal. This one has been repaired by these two, and these two are equal. Now, if these forces are equal, what are we going to do? How can we find it? Remember the vector sum of this thing. We say if the forces are equal, it's just the sum of the forces. When they talk about sum of the forces, we are talking about the addition of the forces. So the force, which is denoted by letter F, is going to be equal to 9 times 10 raised to the power of 9 of Q1, Q2 all over R square. all over r square. Remember, this one is not a vector nature of forces. This one is not a vector nature of forces. That's why you are not seeing vector on their heads. This one is not a vector nature of forces. So F, which is going to be the sum of the forces in order to find the force on each one, this F here is equal to 9 times 10 raised to the power of 9 of Q1, Q2 all over R square. Alright, so Q1, Q2 are the charges, while the R square here is the distance that separates the charges according to Charles Coulomb, who stated Coulomb's law. Alright, so if you have something of this kind, what is the next step? Alright, this is F, which is the force. The F, which is the force, is going to be equal to 9 times 10 raised to the power of 9 times, or hence is this should be in bracket. So hence these things are in bracket. No need of putting the times, because we have charges that we are going to look for, and this one is in bracket. Although the brackets which I put here is not necessary, you can put, you cannot put, they are not mandatory. So 9 times 10 raised to the power of 9, open bracket. Let's open this bracket. If we open the bracket, what are we going to find? We're going to find Q1 and we're going to find what? Q2. So what is Q1 and what is Q2? As you already know, the charges are what? The charges are this. These are the respective charges. They are the respective charges. So we're going to have 5 times 10 raised to the power of negative 6. Alright, close it. This is for the first charge. So the second charge, open the bracket, still write 5 times 10 raised to the power of negative 6. Why are we writing 10 raised to the power of negative 6 and 10 raised to the power of negative 6 is not on the equation? Why are we writing it? But before then, don't forget to close the bracket. This bracket is very, very important. Alright, so why are we writing this? 5 times 10 raised to the power of negative 6. This negative 6 is just telling you we have 0.0000001. If you have something 0.0000, this is 1 2 3 4 5, and then you have 1, you can write this thing as 10 raised to the power of negative 6, because if you move it, as you already know the calculation, you're going to have something of this kind, so it doesn't really matter. Okay, so let's come back to our problem, which F is equal to 9 times 10 raised to the power of 9 of open bracket, 5 times 10 raised to the power of negative 6, and 5 times 10 raised to the power of negative 6. We are dividing this by 0.1 square. Ask your question. I know you are confused. Why do you have 0.1 square? Alright, but don't be afraid. We have 10 centimeter. We have 10 centimeter. And you don't need a prophet to tell you that this thing is in centimeter and you're going to convert it in meter. So if you convert this thing in meter, you are going to have 0.1. And remember, the R is squared. That's why we squared it here. But some of us, we still don't know how to convert centimeter to meter. Will I tell you everything? Okay. To convert it, you are going to have 10 divided by 100. If you divide this equation, if you divide this motherfuckers, you're going to have 0.1, which is the one we have here. And this one is carrying square, so it is going to carry square, which I believe is clear. Should we continue? Alright, so if you do this calculation very well, if you multiply this thing, you punch this thing on your respective calculator. Don't use your phone calculator before you come and get the wrong answer. If you punch this thing on your calculator, you're going to have equal to 22, which is 22.5 Newton. You're going to have 22.5 Newton. Alright, so what is the resultant force? What is the resultant force? This is the force that you get on the charges. So what is the resultant force? Remember, the resultant force is not on the question, but the question is telling us to find force on each charge. So a resultant force like I told you in the previous video, that is a force that we have both magnitude and direction of two forces put together. So that one resultant force represents other forces. So how can we find the charges on each charge? How can we find it? We are going to look for what? A resultant force at C. A resultant force at C. Where is C? Look at the C, because this is the one that is being repaired. So this one has been repaired by this one, so we use this one, so we did not touch this one. So we are going to look for this one. Hence it is the resultant force, which I believe is cleared. All right, so the resultant force at C, remember C is having an angle. So right, so we are going to see the resultant force at C is going to be equal to 2F cos 30 degrees. 2x cos 30 degrees. Resultant force at C is equal to 2F cos 30. Okay, why are we having this expression now? I know some people will be asking where this 2F cos 60 come from, whereas from the question we have 60, while here we are having 30. Okay, thank you. If you have this problem like this, you should use your normal algebra, as you already know. This 2F is telling that we have two. This F stands for what? For force. This is telling that we have two force, and this cos is just the angle between the what? The C. And this 30, if you do 2 times 30, you are going to have 60, which is the angle here. And I believe it is cleared. All right. So if you punch this on your calculator, this very expression on your calculator, what are you going to have? You're going to have a resultant force at C will be equal to what? Then 2F cos 30 will be 2. This 2 is because we are having two forces. It's 2 times, then this force is what? The force you have as you solve. The force is 22.5, so you're going to have 2 times 22.5. Please don't include the Newton here, and because I asked you to pick this and put here, you might mistakenly take the n as well, leave the n, but we are going to bring it. But for now, just suspend it for now. All right, times root 3 over 2. Ask your question. I know you are confused. All right, where we get to root 3 over 2. All right, root 3 over 2 is cos 30. If you punch cos 30 on your calculator, for those of us that are using Casio, if you punch cos 30 on your calculator, this is the same value is going to give you. So root 3 over 2 is just cos 30 degrees, which I believe you are cleared now. So if you punch 2 times 22.5 times this expression, what are you going to have? All right, you are correct. You are going to have 38.97. Now you bring your Newton, measured Newton. Then this is the final answer. All right, before the video ends, I want us to still go back. They say 3-point charges of these charges. These are the 3 charges are placed at the vertices of the equilateral triangles, and I told us what is equilateral triangles, which has a side of 10 centimeters long. Find the force on each charges. So therefore, using the formula, we have F is using the formula F. Remember, the formula is F is equals to KE Q1 Q2 over R square. So this KE is the 9 times 10 raised to the power of 9, while the Q1 Q2 is these ones. This one is the KE, while this one is the Q1 and this one is the Q2, while 0.1 square is the R square. Why do we get 0.1 square? We convert 10 cm to meter, and we have this expression. So looking for a resultant vector at C, because C is having the angle, looking for the resultant vector, you put the two forces together, you have 2F, this is two forces, and then you have cos 30. Why do we have cos 30? Because if you do 2 times 30, you are going to have the normal 60 you have here. So if you punch this thing on your calculator, you are going to have this as your final answer. Thank you very much for paying attention and watching. I still remain Sir Vitalis, the course rep mechanical engineering 200 level. Thank you. Don't stop learning. Who stop learning, stop living.